This is how the night sky looks like, and those tiny shining lights are the most fascinating object about it. Even as a kid, we used to wonder what are those tiny shining objects in the sky. Then we learned that those are the stars, just like our sun. But why don't they appear like sun? Then we grew up and we learned from our academics and other sources that it's because they are very far away from us that makes them appear tiny in compared of sun. Even dwarfs like sun are supermassive black holes which are also actually stars. But there is something between these two. They are neutron stars. We are going to learn about them in today's episode. This is Shobit Yagi from the Unwoggling Physics, and let's begin our journey into the deep space. Stars are heavenly bodies that fuses matter together. They fuses one or more particular element to make a different element. In this process, they release energy in the form of electromagnetic waves. These electromagnetic waves, which falls on the visible spectrum of wavelength, they makes appear the star shine. Let's go back to anatomy of an atom. It contains three different basic kinds of subatomic particles: electron, proton, and the neutron. The formation of neutron occurs when an electron and a proton fuses together to make a neutron. These neutrons are basic building blocks of a neutron star. Well, neutron stars are formed when a massive star runs out of fuel and collapses. The very central region of a star, the core, collapses and crushing together every proton and electron into one neutron. If the core of a collapsing star is between 1 and 3 solar masses, then these newly created stars can stop the collapse, leaving behind a neutron star. But if the star is big and contains more mass than this, then it will continue to collapse and it will become a stellar mass black hole. This collapse leaves behind the most dense object that we know, the object which has a mass of a sun squished down to the size of a city. These stellar remnants measure about 20 kilometers across. One sugar cube of neutron star material would weigh about 1 trillion kilograms on Earth, about as much as of a mountain. Now we'll know about the Chandrashekhar limit. Well, this is the maximum mass of a white dwarf star up to which it stays stable. Beyond this mass, it starts to turn into a neutron star by fusing its subatomic particle into neutrons. Many neutron stars are likely undetectable because they simply do not emit enough radiation. However, under certain conditions, they can easily be observed. A handful of neutron stars have been found sitting at the center of supernova remnants, quietly emitting X-rays. More often, though neutron stars are found spinning wildly with extreme magnetic fields as pulsar or magnetar. In binary system, some neutron stars can be found accreting the material from their companion and emitting electromagnetic radiation powered by the gravitational energy of accreting material. Two general class of non-quite neutron star as pulsar and magnetar. Now we'll try to know about pulsar in detail. Most neutron stars are observed as pulsar. Pulsar are rotating neutron stars observed to have pulse of radiation at a very regular interval that typically range from milliseconds to seconds. Pulsar have a strong magnetic field which funnels of the particle along two magnetic poles. These accelerated particles produce very powerful beam of light. Often the magnetic field is not aligned with the spin axis, so those beam of particle and the light are swept around as the star rotates. When the beam crosses our line of sight, we see as a pulse, or in other words, we see the pulsar turn off and on as a beam sweeps over the earth. One way to imagine this is to imagine a lighthouse. Imagine you are standing at a distance from a lighthouse during the night. At night, a lighthouse emits a beam of light that sweeps across the sky. Even though the light is constantly shining, you only see the beam when it is pointing directly to your direction. So only we see it when beam hits directly towards Earth, and it disappears when beam doesn't. That is where it got its name from. Because it pulses, that's why it's called pulsar. Most of the time, the neutron stars are pulsar only. But sometime a star turns into a neutron star which have another type. Another type of neutron star is called a magnetar. In typical neutron star, the magnetic field is trillion times that of Earth's magnetic field. However, in a magnetar, the magnetic field is another 1,000 times stronger. In all neutron stars, the crust of the star is locked together with the magnetic field so that any change in one affects the other. The crust, under an immense amount of strain, and a small movement of the crust can be explosive. But since the crust and the magnetic field are tied, that explosion ripples through the magnetic field. In a magnetar, with its huge magnetic field, movement in the crust causes neutron star to release a vast amount of energy in the form of electromagnetic radiation. A magnetar called SGR 180620 had a burst where in 1/10 of a second, and it released more energy than the sun has emitted in last 100,000 years. Magnetar are considerably new discoveries, and there is a lot yet to be known about them. Well, this was the story of neutron stars. If you like this, you must stay tuned for the next episode where we're gonna discuss about another space object. You can also suggest the topics that you want us to cover in our future videos. We appreciate your time that you have invested in this video. Till then, keep feeding your curiosity, and I'll see you in the next one. Thanks a lot for watching.